All right, so today in class we're going over comparison tests. So direct comparison is meaning you have two infinite series with positive terms. So if you have one series, the sum of b sub n that is convergent, and b sub n, all of the terms of that series are bigger than all the terms in the other series, well, then that means that the sum of a sub n has to converge, okay? Now, if the sum of b sub n diverges, and these are all positive terms, and the sum of a sub n, sorry, that's a sub n, diverges, okay? So if the sum of b sub n diverges, we have all positive terms, and b sub n is smaller, all the b sub n's are smaller than a sub n's, well, that means that the sum of a sub n would diverge because it's bigger, okay? Now, direct comparison tests, they work, but they're not really the best, okay? We have a different type of comparison test that is actually it works out in more cases than just trying to do some type of direct comparison, okay? And so the other type of comparison test that we will deal with is a limit comparison test. So the limit comparison test so it starts off with the same type of idea. Suppose that we have two infinite series, the sum of a sub n and the sum of b sub n are series with positive terms. Right, and the limit as n tends towards infinity of a sub n divided by b sub n equals some L, which is greater than 0, okay? So if you can get the limit of that ratio to approach a number, then the sum of a sub n and the sum of b sub n both converge or diverge. So the limit comparison test, because of the fact that you don't have to create some type of inequality, and you just are evaluating a limit, this one ends up being a bit nicer. It works out more often. All right. But we do have two special cases that are going to be associated with the limit comparison test. There's the zero case, so if the limit as n tends towards infinity of a sub n divided by b sub n equals 0, and the sum of b sub n converges, then the sum of a sub n converges. And we have the infinity case. So if the limit as n tends towards infinity of a sub n divided by b sub n tends towards infinity, and the sum of b sub n diverges, then the sum of a sub n diverges. Okay, so that's the 0 and infinity case.